Hello. So, though this lecture is a little to do with 3D printing, we still have a starting point where we need to start. I just thought I will remind you from where I left off here. You see here, this is the original 3-pin series pass regulator. You will notice here in this case wiring and the whole thing is relatively easy. All I have is I need to make a little bit of insulation here. I have heat shrink sleeves, then there is a reverse protection diode, and the whole thing has been nicely encased in a aluminum box. You see here, and I have an advantage here. The moment it is made of a conductive material, in this case aluminum, this whole thing is very cheap. Probably this costs maybe to fabricate and all that, no, very little, and then in the shop maybe it can be sold for 1 rupee, because it is not any special specially designed extrusion. It is just a long aluminum C channel that is cut, and then a hole has been drilled, and then only thing is, in this case for our safety we have made a special one clamp like thing, and we have pasted it, and that too has been made to ensure that there will not be any shorting. So, in this case overall a linear regulator is very cheap, there is no problem, and the main heat dissipating component can form the box also. However, when we switch over to any of these elements, like these two elements, these are all switching regulators. You have seen this, no? It is about the same size as this, there is no problem. It is that is the reason, no, why in fact I picked up the switching regulator also is about the same size, except that it is full of electronics and full of places where it is likely to get short circuited. So, first obvious choice will be for us to have a non-conductive enclosure. So, the most common way of making a non-conductive enclosure is probably make a C, and then I put one more C on top of it, and now comes the slightly involved topic about it. Now, if you kindly see the channels here, I will just take you to seen something here, the same thing, the same circuit, except that it already comes with, there are no mounting holes. There is only a small provision for a heat sink here, otherwise it comes all the thing with its own output jacks. This particular thing now is an output, and then we have an input jack here. So, the previous picture shows you this is the input and this is the output. So, in this case it is probably relatively easy for us to just fabricate a cover, and there are no electrical connections involved, and in fact we can make a tube like structure, perhaps take a tube in which we can push this through, and on one side we put an insulator, and overall we are in good company. Making a enclosure with our rapid prototyping for this is relatively simple. All we need to do is take the dimensions of the box outside, okay, this dual USB thing, and then miraculously they have made all the dimensions such that everything is within that height. So, a tubular structure is easy, and then the tube can probably stop here with if a step if you want, otherwise you make an opening, make a barrier, and then you have in and out like this. There is absolutely no issue about it at all. Now, you see this is slightly different thing, similar concept, except that both in and out have this screw on connectors. Advantage of screw on connectors is no more wiring is required, no more soldering is required. So, if I make an enclosure for it, I can ensure that the enclosure nicely sits here, and again for our sorry, I hope I have not deleted it. For our convenience and to avoid engineering drawings, I will tell you why the engineering drawing issue is. In fact, they have put a workshop scale and photographed it, saying what you see is what you are likely to get. So, it is easy for me to see that if I see this right edge, it is going to be around 42.5 millimeters, and then it is easy for me, absolutely easy. And then same thing with the other dimension also. Then all the drawings things are given here, and you see here this is a 32 mm by something else, same PCB without the components, except that here you need to solder things, either you need to solder or you need to use a special connector and so on. Usually this is a very good starting point of our projects. So, here both the mounting holes are on the same side, which is different from the earlier one. If you see here now, the mounting holes are all the 4 corners. Then we come here, we have only 2 mounting holes. Same thing here, the other dimension it is given. So, if you check carefully, it is 20 mm by some 32 mm. Within the 22 mm, we know at least what is the area that is required. Why they give these is, these are generally used for printing into some other circuits. Now, you see at the back, we have again this same 2 mounting holes, and there is a provision here for probably a heat sink. Probably, I won't say it is a heat sink, or if you go back you will probably check whether some other thing is, I am sorry, something else is included in that. You see here, yes, it is for a heat sink only. So, we see here there is actually the actual chip is here. Okay. This is a toroid, or what do you call, a transformer to increase the thing. So, after you look at it and all that, these 4 holes may be for via holes, and then you see carefully everywhere this red thing represents the copper. So, this copper has been made such that things are very nicely done. Now, let me what do you call stop here, show you these 2 things. Have a look at these 2 things. Sir, can you get us a closer look? They look about the same, is it not? If I now twist it, they look about the same, except that when I turn it over, you will notice that the mounting holes are opposite. It is not about twisting it. If you have to twist it here, you see here, still they come on to the opposite direction. So, this is the case where making a what do you call a general purpose enclosure is a little problem, where our thing will help. Can you see here, we have the mounting holes here, one hole is here and one hole here, top left, bottom right. In this case, top right, bottom left. So, if you follow the particular type of sequence which I have shown you there, including I have made an outer enclosure and all that, then you have a look at these components here also. You will notice that these capacitors are taller, okay. They are projecting beyond the surface, they are just projecting beyond the surface, while these capacitors, they are about the same size, they are about the same size, slightly in fact bigger, and then they do not project beyond this. So, if you take a dimension from this and if you take a dimension from this, and miraculously you see even the position is slightly shifted, it is not as easy as we think, and overall the dimension of the circuit itself is very different, one is bigger and one is smaller. This is where it helps for you to modularize your design, have an outside box, have the mounting studs and all separately, and have a heat sink position which is separately, and so on. Now, let me what you call allow me to go back to the drawing stage. I brought you and probably left you here yesterday. So, I have a printed circuit board which has 2 openings here, then I have a small aluminum plate, just loosely I have shown a what you call as if something is attached. It is not attached actually, if you go and push it here, it is very convenient, it just goes on top of it. In this, it goes and sits on top of the that printed circuit board. Okay. And makes a contact. So, maybe if I put it in this mode and then put it in the 3D shaded mode, it will probably make more sense. So, in the shaded picture you can see there. Only for convenience I have pushed the printed circuit board up. Now, I will push it down for you. And one thing which was quite okay, and now I will just show you why it is not okay, is this very fancy opening I have given here, thinking it will make it look good and maybe people will want to buy the product and so on. See this here, I had a tuning thing and then this was kept here saying it will help. Now, we come into the little bit of problems with construction of anything which involves this this thing. I will now hide this to make sure that it will not interfere with our arguments. Now, you see why I have kept these bosses separate. These bosses are kept separate such that depending on the batch of the printed circuit board I have, I can move them to align with the product that we have got, because it is likely to be different. Anyway, right now I will hide them, right now I will hide the printed circuit board also, and just for this thing I will hide this also. Now, here we get into a very interesting, I will not say whether you, I do not know whether you should call it a problem or issue which need to be solved. See, if I were to build a tapered piece like this, and which is again in reverse, you see it is part of the box. The building up will start now. This is the bottommost layer, the bottommost layer the build up will start. Now, we have a very peculiar, you see here an angled surface which needs support from the bottom. So, the algorithm there will try to build lot of support material here, just for to make things easier. I will just try to draw a polyline, and you see if this were the base, the support material will start being built like this. Which is incidentally a big waste of effort, and further you will not get a smooth edge as we have shown here. It is fine because the algorithm itself takes layers, and then in layers will the thickness of the layer will represent the z direction granularity, and x and y resolution will depend on granularity in the other direction. So, we may or may not be able to support, this is just a waste of material. So, is there a way of getting over this problem? So, probably the easiest way of getting over the problem is, first of all, find out whether this is really necessary. Do we need to build a very complicated structure like this? Reality is no. While in injection molding once upon a time, and then with the what do you call a little bit of aesthetics and industrial design, while it made sense, similar function can easily be achieved. Instead, if you just make a cylindrical structure here like this, but then one thing you notice, there is no fillet here, and then right now for convenience sake we just made it straight. Advantage being the layup will start at the bottom, and then slowly after this thickness is built up, next layers will start building here. And it does not matter even if in the plan where it is circular, it is not such a big deal for us. See, even in this view, if it is circular, it is not a big deal, rather it is not a big problem for us. So, the what you call the fused filament device, that head will start building up all these things. Once again, depending on how energetic you are feeling and so on, probably making it a square also may make sense. Just make it a square, same way here, just for convenience I have made it a circle. Nothing prevents us for making a simple prismatic object into a square, because building up is easy. Right now, otherwise every time it goes and comes back and all that, no, little bit of jaggedness will come here. Is there any other way? Yes, it's for you make an octagon, make a square, or make something which is there, because what we are interested in is the center hole here. Now, you see, building an object like this is relatively very simple in the amount of support material and the amount of time required will reduce tremendously. I hope you got my point. My point being that if you make all that fancy things which are required for maybe in mass production, in this case we can optimize very well to do this. Let us say you still liked that the concept of a groove and it looked fine, instead of sticking to this vertical inclined thing, maybe some other way we can make. Why not convert it into a vertical channel? Maybe you can convert it to vertical channel, make it like this, and then make the hole appropriately correct size, and then you make a this thing. Further, you will notice when I try to make a hole, the solid modeling package has made a very what looks very cute. You have seen this, no? A very beautiful, really cute looking thing has been made, which at one level, while it looks good, we do not know how well it actually builds up. See, nice, no? It looks nice as a nice thing and all this here, probably misplaced, meaning I mean you do not need that type of thing, all you require is a nice groove. In contrast to the groove, the other circular feature also is equally good. Now, I will presently what I will do now, I will unhide all this whole lot and then see what is sitting where, and then put it together and see what best we can do. So, this one no, I will just delete it. Right now I do not want it. Okay, this stuff I have still. Slowly I am reaching the point I wanted here. See that, except there is still no small what I call minor this thing is there. This top no has not aligned itself perfectly, but then it is okay. I'll just put up with it for the moment. I know how to correct it. Eventually I will put up with it. So I have got a heat sink device here, and just fine. No, I think I will improve it. I will just delete it. Start with the proper heat sink device. and then again one more time I will start with the surface, which will start with a plane corner to corner. This is my heat sink proper, this is the cover. I see if they are Boolean themselves. Fine, nicely it has got Boolean. Now I have got a reasonably good looking box with a place for the printed circuit board to sit, and then I have got a heat sink which will go and press on that, except two features here, that mounting hole of the printed circuit board has not been transferred here. So what I will do is, since I have got the bushes in place, right now I will close the printed circuit board, make use of these two bushes and then extend these holes there. So what I do is I try to create a solid using a planar curve. This is the planar curve. Same thing happens here. You see here I have got two things which will eventually can be made into this cover. So this is the cover I have created just now. So I have transferred those holes to that, then I will do the difference from here. First set of holes, second hole I will create here. See, now I have a reasonably good looking completely enclosed box, and there is a place here for me to tune the printed circuit board. Remember, the PCB is being mounted obviously upside down. Can you please show this, sir? I have a printed circuit board here, the heat sink is sitting from here, and the other side is where the tuning and so on will come. So the thing is being built upside down like this. This is how the device will come, this will sit here, and because I have got these two mounting holes and these buses, it will go and sit on the bus, and the heat sink will sit here, and the same holes which are given here are given on top. Now I need to take a call on what to insulate inside. Do I put a small insulating layer, and something which is equally probably equally important is, do I pot the whole thing? After finishing this, there are heat conductive but thermally conductive but electrically insulating potting compounds are there. So I nicely put everything and then inject the potting, some are two components, some are single component things. Once you inject it and put it together, two things it has. Intellectual protection is only a small part of it, that is not the important. More important thing is, the moment you pot it, conduction and all will improve, there will not be any air pockets at all. Any time conduction of that what you call polyester or any of the resins is much better than air. And secondly, it is completely immune to any vibration, any shock or anything like that, but potting itself is an art. So I have now here, you see, I will now just turn it over. Okay, that is the bottom portion. This is the heat sink part. Heat sink has holes. I will now hide this, and this is how finally this is going to be my final job which I am going to fire on the machine. It is a little simple, it looks really quite nice and all that, except that first thing you will notice here is, sir, why is this boss so big, is it not big and is it not small and all that. This is where you have to need a call. Logically the just same amount of material which I have left here is sufficient for here. Typically a minimum of 4 mm, 3 to 4 mm is required, and this hole is for having a self tapping screw which goes inside. You understand, no? Self tapping screw which goes inside, and this one and so on like that. Why I have made it little bigger than normal is I have a nice area which it sits, the maximum possible area, that is I have included here. You understand, no? So it looks big, there is no reason why it needs to look big. The main difference between here and the injection molded part is, if we were to make a part like this in injection molding, one of the first things that will happen is, because of the large cross sectional difference, we end up with huge sink marks and the material will not flow at all. It is a very poor design for injection molding part. But in the case of making a quick good prototype in our 3D printing, this is probably the best way to make things. You got my point? This is where the slight difference is there. Now right now I do not know, for some reason this refuses to, what do you call, get unioned with this. I will see whether it will still continue or still it does not like each other. It got union, no problem. Hey, very good, surprise. So I have got a beautiful object here, which is, the whole thing is integral, everything, no. Now only this bottom portion I will see if I can attach it to this, and then I will show you some other interesting objects and which you like here, solid. Then we have a union. Good. Little small error has happened, do not worry too much about it right now. The whole thing has turned out to be a single object. Because of a little projection, probably that thing has happened. Now to make this a little more, let us say if you are to be made in injection molding, we will invariably end up with having to give fillets here, otherwise it becomes very, very weak or stress concentration will occur. In this case also, if you suspect that there is too much of force coming here or something, it may be possible for us to give fillets. Okay. Loosely I will try, I will see if it just one surface I will try to fillet and show you how it comes. Yes, I have a smooth fillet there. You have seen this. I will see now whether I can do a similar fillet here. Seen here, what looks like an obviously cute fillet has happened there, and correspondingly on the inside thickness, see here in the inside thickness I have one more time. This is conventionally what you are likely to see in a injection molded part, except that as I told you here, it does not build well when we come to our this thing. So we avoid these things as much as possible, we avoid such things. These are much easier way will be to have steps. Steps are much easier to build, even chamfers do not build well, in spite of whatever the manufacturers claim. see here, at least it looks nice, and it does avoid stress concentration which is likely to occur, the same thing as we have in the other thing, except here now you have to take a little more care to see what best we can do about it. See there, it looks quite okay. So, right now I will stop this particular experiment, I will stop here, then I will try to take on just a flat pace and show you how we can attempt to build these things here. So, I will start with a fresh drawing instead of see, as before I will start with a what do you call a surface, probably a plane. I have a beautiful surface here, okay. Nice surface, then I also will make a small curve to build a imagine this is the pilot hole, and then I represent the material thickness here by this, okay. So, I am just creating a step here and trying to see how well I can create a solid. I will use these two and create first of all a solid, oh sorry, no, it will not build because these are there. So, I need to build the other way only. I need to build a solid directly from I have got a thickness here, see this is a very simple conventional thing here. So, this where I thought I will what I call spend a little more time with you. If you have to just fillet it or even chamfer it and do it, it does not build well. Instead, our rather experience has taught us that I will start here, you see that circle is still kept there. I will try to make a small offset out of it. I will build a small step here. Next, I will take the next two circles. This in general is a much better way of creating a what is equivalent to a fillet. I have just exaggerated, intentionally exaggerated it. Generally, if you just have 3 times the resolution they talk about. If it is 0.1 mm, say 0.3 mm diameter is sufficient, and then the same thing here, if let us say the resolution they claim is 0.2 mm, make something which is around 0.6 mm width here. So, we have 0.6 mm width, 0.6 mm width here. Now, same thing about the building of the layers. If they say the layer resolution is say some 0.5 mm, make at least 1 or 2 mm like this. A device, what you call, thing like this prints continues very well without any problem. Seen this here, no? Prints very extremely well. Since I have not union date, I still have an option of playing around with it and see if I can make this hole through. I am just completing that hole there. See, I have a opening here. This is probably what we wanted, and we have achieved it. There is no problem at all. I have a beautiful an object with an opening like this, and once again same consideration what we have, generally we would like to have a smooth surface. So, having built up this inside, we have a little provision here. When we see the cross section, we can try to make the cross section as convenient as possible. So, I will probably use this inside. If you see, I had this whole thing, I will see if I can use it for creating one more thing here, saying I will create a solid using one more of this planar curves. I have a planar curve here, and directly now when I turn it over and see a similar type of a structure which I created that side, now I have managed to create here. We have this here. Oh, something is stuck inside. I will see if I can remove it. I have the opening here. I only the cylinder I couldn't do properly. Now I need to take the cylinder out on the other side and see. I have a projection like this here on the other side, no. Similarly, I have a step there like that. Instead of depending on a chamfer, I will try to make a bigger and bigger these things here and try to, just like I have a structure here, I can have a similar structure on the opposite side, complement of it. Right now, because of some my monitor problem, I am not able to judge what is happening, and anyway let me check here. No, I have lost one of the objects which I have created. I am slightly better. I have this projection on the other side, then I have a depression here, and instead of creating a full fledged chamfer, I am able to make something like this. I can make it in further steps. So, I will just try to go out and see whether instead of taking it so deep, yep. I think I am slightly better this time. You have seen this, no? I can see what look like obviously a few steps here. On the other side I have this, and then whatever I wanted to construct, no, that cylinder with an opening inside, it is very easy for me to now construct the whole thing. And then this is the boss which I was talking to you about. The issue here is, instead of creating a chamfer, so if I go back right from where I have started, I hope it will undo all the way back to very beginning. See, I started here saying this may lead to a little bit of stress concentration here, so some crack may start and all that. I need to fill up this area. Instead of filling it up with a automatic command which is already available for me. So, if I boolean this to, I have a beautiful command which will help me in what looks quite good here and convenient is unfortunately in the case of building it is not very convenient. So, I just wanted, what I wanted to tell you is, I will try to make a small what do you call, I have an edge here, say I take this curve and start building see a thing like this, no, features like this, and even just a simple 1 or 2 thickness devices will be sufficient for me. And on the other side, same way, instead of it being projected out, the similar object can be taken on the other side, and if you subtract it from there, I have features which are relatively stable, relatively good, relatively easy to build. If you are building it like this vertically from here, no, right now if it is being built vertically like this, there is no issue, these things will build very well, because the device will come here, do everything like that. Now let us say in the horizontal direction and then it is curved like this, we end up with serious problems of material and so on like that. There you need to any horizontal openings. The same thing, imagine this was in the horizontal direction. So, instead of being like this, imagine now this, it is still tricky to build. So, lot of support material is there, lot of waste material is there, lot of other way of building it and so on is there. No, here you need to make a little bit of what you call your own judgment and see how best you can do it, and then I will see if I, after we go to the machine, we will be able to show you a few things. So, for today let me keep that aside. I have come part of some way. Unfortunately, things are very rarely so clear, saying we have insulated part and then we have a conveniently printed circuit board, and in this case the cover of this can itself, no, an aluminum plate or conductive plate can come and clamp it, and then seems to be okay. Not true all the time, unfortunately. Unfortunately, we also occasionally end up with things like this, which are metallic components. I have a metallic component here. I think all of you know what it is. It is a some power device, some switching device, and then it needs to be attached to the printed circuit board, and then we have a heat sink also here. So, how do you deal with these things in rapid prototyping is do it in two stages. So, you have the printed circuit board, you do everything, you assemble the printed circuit board, make some arrangement. You have here, now we have a small lug here, which earlier was being soldered into the PCB, same thing which is being soldered into the PCB. It is integrated into the printed circuit board. We make some arrangements, probably make a small gap here such that it sits comfortably here. Stand, no? It sits comfortably here, and then we have also holes, and the material can flow through that. So, we have a printed circuit board which sits inside. Then we have a heat sink which comes out, and this is integrated with the that whatever build material we have. So, parts like this which have thermal or electrical functions, somehow we need to make provision for us in our model, like that, saying do we make grooves here when the printed circuit board comes here. Let us say this comes already attached to this here. Do we make a groove that it goes and sits inside? Alternatively, leave a gap. Do not worry about the groove or anything, just leave a gap and ensure that sits here, so that the heat sink will sit outside. Then we can have another cover over it and so on. So, this is a little tough, but it is little easy also. So, I will just this particular thing I will just stop here.